Good morning. Today we're going to talk about area of a triangle, our last formula in our trig unit. You will want to open up your area of a triangle Inspire document and go to your area of a triangle day 14 in your packets because I'll do some of those with you. Okay, first of all in the Inspire, we've always been told that the formula for area is 1/2 base times height. But that formula depends on knowing the base and height, meaning they need to be perpendicular to each other, at right angles with each other. The problem is we don't always know that. Like on page 1-3 in your Inspire, I don't have any right angles. I don't have base or height information, so I need something else. And that is our new area of a triangle formula. Area is 1/2 AB sine C. Not sure why they use K. So if you go to the last page of your Inspire document, it's like your other Inspire documents where you can test this formula. I can make any triangle and find the area of it. It does not depend on base and height. So you will no longer use the old 1/2 base times height formula anymore. From this point forward, you will always use 1/2 AB sine C. When you're done playing with that, let's do some practice. In your lab packet, must do number 1. Again, I rewrite the area formula. The more you write it, the better you'll learn it. And just like with any of our formulas from our formula sheet, we can rename them, and we must rename them according to the information we're given. And so in number 1, I'm given a triangle DEF. That means I need to use D, E, and F in my formula, not ABC. ABC makes no sense in this context. So I draw and label a triangle. The question's asking for area. Here I know angle E and I know sides F and D, so I'm going to use 1/2 D times F times sine E. Now the instructions are very clear about not using a calculator, and that's because I know these values. Sine 30 is 1/2. So I have 1/2 times 9 times 14 times 1/2. I can simplify the 14 with one of my 2's. Multiply the tops. 9 times 7 is 63. We have 2 on the bottom. 63 halves is 31.5 or 31.5. Okay. For another example, I'm going to move to number 3. Number 3. 3 streets intersect in pairs, enclosing a small triangular park. The measures, so I draw myself 3 streets that are forming a triangular park. The measures of the distances between the intersections are 85.5 feet, 102 feet, and 78.2 feet. So I'm going to label all parts of my triangle. Now we're asked to find the area of the park to the nearest 10 square feet. My area formula, 1/2 AB sine C. The problem right now is that I don't have an angle measure. I have all 3 sides but no angles. So before I can use my area formula, I need to do something else. I need to take those 3 sides and substitute into my law of cosines to find the measure of angle C. So first I do C squared equals A squared plus B squared minus 2AB cosine C, making the law of cosines fit for this particular case, and then plug in. So this is really nice review of using your law of cosines. And I do note that you could have named them differently. It doesn't matter. If you're consistent and you find angle B, then you'll use angle B in your area formula with sides A and C. So for the next little section of this, I'm just substituting into the law of cosines. If you're comfortable with the law of cosines and you get it, feel free to fast forward and not listen until I get through that piece. Going to my scratch pad, it's a reminder of doing the math for the law of cosines. And again, this is just stepping through very, very carefully using my Inspire to solve. If you don't need that, if you get it, feel free to fast forward to the part where I find the angle measure and then plug that in to my area formula for angle C. Remember, when you're looking for an angle, you need to use your inverse trig function. Law of cosines uses cosine. So I'm going to inverse cosine that previous answer to get my angle measure. And my angle measure is about 76.9 degrees. Now I can use that angle measure to plug into my area formula. And from here, it's pretty basic. 1/2 times 78.2 times 85.5 times the sine of 76.9. Go back to my scratch pad and type that in. Remember, save yourself time by using previous answer, arrowing up, and copying and pasting. And the area of this triangle, rounded to the nearest 10 square feet, is 3,260. Please remember, you need to read carefully with rounding. Every rounding error on a Regents exam, or my exam for that matter, is a 1-point deduction. Be very careful rounding. Okay, the last problem I want to do with you is number 5. So I have Gregory wanting to build a garden in the shape of an isosceles triangle. So you need to remember a lot of middle school geometry. Isosceles triangles have 2 equal sides and 2 equal angles. Each of the congruent sides is 12 yards. We know the area here, and that will be 55 square yards. We're going to find all 3 angles of the triangle. So I use my area formula, but I know the area, so I have to substitute appropriately and solve appropriately. So area is 1/2 AB sine C. Now I know my sides 12 and 12, so I'm going to call them A and B to help me with the formula. And so the first angle I'll find is angle C. So substituting in, I have 55 equals 1/2 times 12 times 12 times sine C. And to get sine C alone, divide everything by 1/2 times 12 times 12. Again, I go to my calculator, use my fractions template, set things up appropriately, get the ratio, and then inverse sine to find angle C. Again, if you get it, feel free to fast forward and check your answer against mine. So angle C, rounded to the nearest tenth of a degree, is 49.8 degrees. So I redraw my picture just because it helps me. I need to remember from middle school that the angles in a triangle always add up to 180. So 180 minus 49.8 is 130.2. My two base angles are equal, so I divide that by 2, and each of my other two angles is 65.1 degrees. So finding all three angles of my triangle, I get 49.8, 65.1, and 65.1. That's it. Have a great day.